In this video, you will learn about the crucial concepts of features and labels in the context of machine learning for technical analysis. We'll discuss identifying and auxiliary data, features and meta-features, labels and meta-labels. Meta-features are derived statistics from original features, adding depth to the analysis, while meta-labels are secondary target variables that provide additional predictive insights. And let us give you a spoiler. Meta-labels are the bridge between traditional technical analysis and machine learning. We'll explore how each of these plays a vital role in building predictive models. Let's start with identifying data, such as company names and stock codes, and auxiliary data, like the date and closing price. These are fundamental data types, as seen in the first image, and they serve specific roles. Identifying data help in recognizing and distinguishing different companies. Auxiliary data provide additional context or details that support the main dataset, like the date or the closing price. They are not used as explanatory variables, but they help us properly establish and organize the data. Next, we move to explanatory or predictive data, which are often used as features in machine learning. In our table, these include volume, moving averages like the 7 and 21 period simple moving averages, or the 14 period RSI, or the ATR indicator. These explanatory data are crucial as they help the model understand the patterns and make predictions. Finally, we have the predicted data, which represents the target or the output of our model. That is, the data that we want the model to predict. In this case, it's tomorrow's return value, what we want to predict. In machine learning terminology, identifying and auxiliary data are simple, called metadata. We use the term metadata to refer to data that provides information about other data, since meta is a Greek word that in this context, it can be translated as after or beyond. In machine learning, explanatory data are known as features. These features are the variables or attributes that the model uses to make predictions. They provide the necessary information that helps the model understand patterns and relationships within the data, ultimately guiding it towards accurate or inaccurate predictions. This is the reason why feature selection and feature engineering is so important. Meta-features are derived data or statistics calculated from original features. For example, if we have an original feature like the average value of the volume, and we calculate the standard deviation of the volume over a certain period, this new value would be a meta-feature. It's important not to confuse meta-features with feature engineering. While meta-features are specific statistics derived from existing features, feature engineering is the broader process of creating new features from raw data to enhance model performance. Labels are the actual outcomes or target variables that the model is trying to predict. For example, we can consider labels if tomorrow's price will be up or down, the probability of the price to break the Kumo or cloud in the Ichimoku technique, how long will the trend last, how reliable is the patterns, or any of the hundreds of labels we might want as technical analysts. Meta-labels refer to an additional label or a secondary target variable calculated from the original label. For example, if a model classifies the next day's performance as up or down, a meta-label might be the probability that this classification is correct. Consider a model that classifies tomorrow's performance as up or down. We can train a secondary model to predict the probability of that classification being accurate. This secondary prediction is a meta-label, providing an extra layer of information. Traditional technical analysis generates signals, predicts directions, or identifies trend changes. So instead of creating an original model with machine learning and meta-labels, we can use a traditional technical analysis model as our base model, like chart patterns, candlestick patterns, Ichimoku, Elliott waves, indicators, systems, or any other. Then, we can apply a machine learning model to assess the reliability of these original signals in the form of meta-labels. For example, we can add a reliability score to a head and shoulders pattern, indicating how likely it is to succeed. Thus, instead of relying on generic backtesting results, we can know the probability of this specific head and shoulders pattern that we are observing at this moment. The primary model is good old technical analysis, but we use machine learning to enhance it. Don't worry if you don't fully understand it now. We will revisit it with examples in the lecture label selection. The key to unlocking the power of machine learning in technical analysis: understanding the different types of data, identifying auxiliary features, meta-features, labels, and meta-labels is essential in machine learning for technical analysis. These concepts help build robust models that can accurately predict market movements and provide valuable insights.